All right, let's talk about 4.4, graphing logarithmic functions. So let's talk about the shortcut to graphing a logarithmic function. So there's a lot of different ways to think about this, and there's ways to use that 1.5 knowledge that we got when we learned how to transform functions, that general form, and it does move it around all the same way. But I've taken the time to work through this method that I've never seen before, but it seems to work, to do the sort of things that you're going to be asked to do. So here is the steps that we need. So to graph a function of the form f of x equals a times log base b of n times x minus c plus d. So this is the standard form, except instead of a b here, we had to use b for the base, so I put an n where our b normally is, with a not equal to 0, b greater than 0, and b not equal to 1. For any x in the real numbers and c and d at the real numbers. We only need 2 points in the equation of the vertical asymptote. So if you go back and you look at how we did the exponential function, you can see that there are a lot of similarities here. We needed 2 points and a horizontal asymptote for the logarithm, and since for the exponential rather, and for the logarithm we just need its inverse, 2 points and the equation of its vertical asymptote. So all logarithmic functions do have a vertical asymptote, and here's how we do it. We plot the vertical asymptote by drawing the line x equals c if n is greater than 0, or x equals negative c if n is less than 0. So that's the first thing we do. The line x equals c, x is locked in at c, will always be a vertical line, and that's going to tell us exactly where this thing goes. So keep that in mind. Second thing, choose a value to plug in for x such that nx minus c equals 1, or x equals c plus 1 over n. So these are the things that you're going to use. I went ahead and solved this for x for you. This is your value. It's c plus 1 over n. And remember, this is minus c. So if our form has a plus c, then your c will be negative, because it's assumed that it's negative to start with. So if it's the log base 2 of x minus 5, your c is 5. It's assuming that it's negative. So if this is a positive number right here, if this is a positive number right here, then your c will have to be negative in order for that still to work out. Try and keep that in mind. And then you'll plot the first line, c plus 1 over n, comma, well, d. The reason that this is just d is if you plug in, and you can see what happens, if you plug in c plus 1 over n in here for x, the n's cancel. You're left with c plus 1 minus c. C minus c cancels. You're taking the log base b of 1, which is going to give you 0. Because log base anything of 1 is 0. Remember, when we were doing those number lines, when I was explaining this back one video ago, you start at 1. 0 steps at 1. That's where the number line started at. So, of course, if you get 0 for log base b thing, a times 0 is 0. The only thing that's left is d. So there's d. You could have said f of c plus 1 over n. It's just that's always d, so I left it that way. Finally, notice the base b, then choose a value to plug in for x such that nx minus c equals b, or, and here's the other one, x equals b plus c over n. Then plot the second point, b plus c over n, comma, a plus d. So we're taking advantage of a couple things, a couple little facts here. We know that log base b, for any valid b, that is anything bigger than 1 and not equal to 0, of 1 equals 0. For all b, for all valid b's. We're taking advantage of that to get a point, and it'll always be whatever that is. So in this case, we want the nx minus c part, the thing on the inside here, we want that to be 1. Because if nx minus c is 1, then the whole thing evaluates to 0, and it's easy. It's an easy point. That's what number 2 was based on. Number 3 is, if you plug in b plus c over n, you're going to get out b. You're going to get out b, and we're using this one. We're using the fact that log base b of b equals 1 is what we're trying to do. So what we want is the inside, the nx minus c part. We want that to be b. And if we want that to be b, well, you add c, divide by n. That's how you get this, this down here. And you would get that log base b of b is 1. So you're going to have that value work out for you. And then, of course, if you plugged in 1, as in if everything in this box here is 1, well then a times 1, a times this 1, which is what this is, would be a plus d, has to be your output. So you could have written f of b plus c over n here instead, but a plus d works just fine. So you trace the graph approaching the asymptote that goes between those points. So you can see down there that we actually have the example. It says graph the function f of x equals negative 2 times log base 4 of x plus 5 minus 8. So what we're going to do is pause the video for a moment, make sure to get all this down, and give it a shot. See if you can't do this. This exact problem has been given to you, so see if you can't do it. And then we're going to take a look at how to do it. All right, so we're going to graph the function f of x equals negative 2 log base 4 of x plus 5 minus 8 on the axis below. So the first thing that we do is we look at step 1. It says plot the vertical asymptote by drawing the line x equals c if n is greater than 0, or x equals negative c if n is less than 0. N is the number in front of x. X is positive, so it's greater than 0. So we're going to do the first part. We're going to say draw the line x equals c. So it'll be a vertical asymptote, because it's a logarithm, and it will be the line x equals c. C is negative 5. Because remember, that is a x minus c is the standard form, so we had to shift over to the left 5. It's the same way that it worked back in 1.5. So here's where it's going to go. Remember, c works backward in these things because it's an input. That's never changed. Now, there's a couple of points that we're going to need to figure out here. We're going to need to figure out the 2 points. So let's see if we can't do some of this. So we're going to need to find the point c plus 1 over n, comma, d is going to be our first point. And then our second point is going to be the point b plus c over n, comma, a plus d. Those will be our 2 points. So let's look at these. C plus 1 over n, comma, d. Remember what all of these points are. Let's look at this. So a is negative 2, b is the base, b is 4, n is the number in front of x, it's 1, c is the number right here, but remember that's supposed to be minus, so it's the opposite of that, it's minus 5. If it were a negative 5 up here, it would be a positive 5 down here. And then d is negative 8. So now that we have all those numbers, let's just plug them into these forms, and I'll do it in red right here. So what this number is going to become is c plus 1, negative 5 plus 1, negative 5 plus 1 over n is 1, comma, d, negative 8, is going to be the point. Negative 5 plus 1 is negative 4, so this point is negative 4, negative 8. Negative 4, negative 8. Okay, let's try and remember that. Now, this guy is going to turn into this. B plus c over n. So 4 plus negative 5 over 1. 4 plus negative 5 over 1, comma, a plus d. Negative 2 plus negative 8. What is that point? The other point. 4 plus negative 5 is negative 1. Over 1 is negative 1. Negative 2 plus negative 8 is negative 10. So our 2 points that we need are negative 1, negative 10, and negative 4, negative 8. Let's try to remember that. Negative 4, negative 8, and negative 1, negative 10. Negative 4, negative 8, negative 4, negative 8 goes right here. And negative 1, negative 10 goes right here. And that is what our log looks like. Let's scroll down, submit our answer, and there we go. That's exactly what it says. So that is how to go about doing these. So let's look at another one real quick. This one asks us to graph the function f of x equals negative log base 2 of x plus 3. So we need those points. Here's the 2 points, always. It's c plus 1 over n, comma, d. This is the hack that will use the fact that if you plug in c plus 1 over n, it's going to give you 1 inside, which will give you 0 overall. So you fill in everything for this. Again, you can go look through all this if you want to. Your a is negative 1, your b is 2, your n is positive 1, your c is negative 3 this time, sorry, your c isn't -3, and don't let it get you. It almost got me. Notice that it's not like this. That's a huge difference. Your c is, well, there isn't a c, it's 0, comma, your d is 3. Okay, it almost got me there. Your d is 3, and look at that. This is log base 2 of x, like that. And it's easy to get lost in that, so be careful. So we're just going to plug everything in here. C plus 1 over n. So 0 plus 1 over n was 1, comma, d was 3. Okay, that's your first point. And then your second point is going to be the point b plus c over n, comma, a plus d. And that's just hacking the logarithm to get it to spit out those different forms that we showed. So b plus c over 3 is 2 plus c, which was 0, over n, which was 1, comma, a plus d. So -1 plus 3, and overall that will give us, finally, this one up here was just 1 over 1, which is 1, comma, 3 is 1 point. And then our next point is 2, comma, -1 plus 3 is 2. So the 2 points that I need are -1, 3, and 2, 2. And then I also need where that vertical asymptote is at. So the vertical asymptote, as always, will be at the line x equals c if n is greater than 0. It is. So it's at the line, it will be the line x equals whatever c was. Well, c was 0. So it'll be the line x equals 0, aka the y-axis. So let's remember the points 1, 3, 2, 2, and the y-axis. So the y-axis, 1, 3, 1, 3, and the point 2, 2. Right, like that. Those are the 2 points that'll do it. Slap everything in and go ahead and submit it, and you're good to go. That's exactly how that works. So all that you have to do on these is just run it through this form right here. Keep these things in mind. I've made this as dog simple as I possibly can for you. Remember, that's your 2 points. Logarithms will always have a vertical asymptote, and it just depends on your value of n. So the first thing you do is pull all this information out, find your vertical asymptote, run these things through, plot the points, you're done. That's all that there is to this section, and that's all the time that I'm going to spend on this. I'll see you guys in the next one.